Hey everyone. Today I'm going to talk about the top 6 most common coding interview concepts that you need for coding interviews. Let's start with number 6, and that is going to be a data structure called a heap. Heaps are a very common data structure that comes up. There are some problems where actually the entire problem itself is just using a heap, like you're trying to get the minimum value or the maximum value. Or one problem that comes up very frequently is the top k values or something like that. And that's really what a heap is designed to do, because with a heap, there's 2 variations, a minimum heap and a maximum heap. If you were doing a minimum heap, for example, you could get the minimum value from the heap in big O of 1 time, which is very efficient. And when it comes to actually popping that minimum value, or adding a value to a heap, that is done in log n time, which is also very efficient. Let's say if you're building a heap of 10 values or n values, then you can build that heap in big O of n time. As long as you have all the values available from the start, you can build the heap in big O of n time. But if you're manually adding each value to the heap, and you don't have them available all at once, but you have to go through some kind of data stream to add each value to the heap, then that will take n log n time, because adding a value to a heap is log n. And if you have to do that n times, that's how you're going to get that time complexity. Heaps actually also show up in a lot of standard algorithms, like graph algorithms, shortest path algorithms, and things like that. So I think it's a very, very good data structure to definitely understand, because the implementation is a little bit complex. But usually you don't have to implement a heap, you can just use it, and it's very easy to use this data structure. Next up is sliding window. There's this algorithm where you use 2 pointers to iterate through an array, and this is a really clever technique. It's actually a very standard algorithm, and it is very easy to understand, because this is the type of algorithm you can memorize and then apply it in many, many different places. The idea is usually that solves some problem where you have to iterate through an array n times. So if you have to do that n times, the overall time complexity becomes n squared. But there's a lot of problems where you can have 2 pointers and then use them kind of intelligently, and in that way you only end up iterating through the entire array once, and that's big O of n time. You don't have to do nested for loops with a sliding window, you just keep track of 2 pointers. You increment them in an intelligent way, and then you get a very efficient algorithm. The next algorithm is going to be binary search. I think every developer will learn this algorithm and usually think it's pretty simple, at least conceptually. The whole idea comes from this. If you were guessing a number between 1 and 100 and you got some kind of feedback, like if you got the wrong answer and you knew if it was too high or too low. Of course, if you were guessing between 1 and 100, you would guess 50, because if it was too big, then you would eliminate all the numbers that are smaller than 50. If it's too small, then you'd eliminate all the values larger than 50 and then just continue to do that. Just take the halfway point between whatever you're trying to determine. So in that sense, it's a very simple algorithm. Usually binary search problems are really obvious that you're supposed to use binary search. You're given some kind of array, and you have to search for a value. Usually you can search for that value in big O of n time, which you might think is efficient. But there's a more efficient algorithm. Binary search log n is actually a lot more efficient than big O of n, which is why binary search is an important algorithm. But there's also a lot of problems that are easy once you know that you're supposed to use binary search. But it's not obvious that you are supposed to use binary search. Sometimes you might think it's a sliding window problem, but in actuality, it's a binary search problem. So I think that's kind of the hard part about binary search. Sometimes even identifying the problem needs binary search. Next up is going to be actually 2 algorithms that are very similar: depth-first search and breadth-first search. These are 2 incredibly common algorithms. probably the most common algorithms you'll use in coding interviews because they can be applied in so many different places. They can be applied to trees, but they can also be applied to general graphs, whether it's a 2D matrix-type graph or a graph of nodes and edges. DFS and BFs are actually the building blocks for more complex algorithms. Things like Dijkstra's algorithm, shortest path, Kruskal-Prim's algorithm, Bellman-Ford. Most graph algorithms build on top of DFs and BFs. So if you have a very good understanding of DFs and BFS, you can actually solve a very large number of problems. Not just graphs, but also trees, and even more. And I would say if you can get to the point where you can write a DFS algorithm or BFS in your sleep, you're going to be in very good shape for coding interviews. Because these are very standard algorithms. Once you've written them so many times, it becomes like second nature. But when you're a beginner, these algorithms can be pretty daunting to learn. Next up is recursion. Recursion is applied in so many places, and it's also used in graphs, as well as many other categories like backtracking, sometimes with dynamic programming. If you're talking about the memorization solution and in so many other ways, recursion is just a huge category, and I definitely recommend getting pretty proficient with recursion. You definitely want to have a good understanding of the base case, the recursive step, and just the general idea of what's going on with the recursion. You should understand that recursion does take extra memory to do. It's not free. You should understand what's going on with the call stack as you do recursive algorithms. And I think this category is probably one of the most difficult for people to learn. I think recursion is the reason why people think graphs are hard, trees are hard, backtracking is hard. It's usually because they don't have a very good understanding of recursion. Last up, the number one pattern I think you should understand for coding interviews is definitely HashMaps. It's the most simple thing on this list probably, but it's also the most common. There are so many problems that can literally just be solved by using a hashmap. The famous problem is probably toSum, because instead of iterating through the entire array to search for a matching value with toSum, you can just literally use a hashmap. That's the entire problem. If you use a hashmap, then you solve it efficiently. And the important thing to know about a hashmap is basically that every operation that you do on it, pretty much any operation at least, can be done in big O of one time, in constant time. Now, technically that's not true, but basically on average, it'll take big O of one time. And usually 99 of the time in real interviews, people will just say, okay, yeah, it takes big O of one time to do that in a hashmap. You don't really need to get too technical with it. Adding, removing, and searching for values in a hashmap is very efficient. And even in a lot of the other categories I was talking about DFS, recursion, and sliding window, hashmaps actually come in handy for those as well. So even if the hashmap itself won't solve the entire problem, hashmaps are always used as utility data structures to do things efficiently. If you don't have a good understanding of hashmaps or know how efficient they are, then pretty much any coding interview problem is going to be challenging for you. So those are the top 6 coding interview concepts I think you should be preparing for. I think if you are preparing for your coding interviews and you don't feel like you have a really good understanding of the 6 things that I talked about here, I definitely recommend studying that before you get into more complex things like dynamic programming or getting into those really advanced and obscure algorithms, which most likely you're probably not going to see in a real coding interview. You're more likely to see the things that I talked about here. As always, thank you so much for watching. Don't forget to like and subscribe if you found this helpful.